So Li Meng is going to tell us about the work that's being carried out at Peking University together with Professor Zhou Mingwei, and it's about the Trustee software repository, which will be very soon coming to OW2. So we already have the installation, and as will be part of the Squat program extension in 2013. And so now it's up to you for 15 minutes.
Okay. Good afternoon, everyone. I'm Meng Li from Peking University, Beijing, China. And I think I'm the only Chinese guy here right now. Yes. Actually, this presentation should be presented by Minghui Zhou, but she didn't manage to come to France, so I will replace her and present some research work undergoing in our university. And actually, the presentation can be divided into two parts. The first part is I will introduce, give a brief introduction of the Trustee software repository, and the second part I will introduce the Peking Lab data center. And this is the agenda. And first, the background. Software reuse aims to improve software development via reusing software resources, and the software resource repository is the infrastructure that provides the software resource management mechanism to support software reuse. And the TSR system stands for Trustee Software Resource Repository, is to provide the mechanism to manage the software resources, and especially the TSR system support the trustworthiness evaluation and to help users to use trust software. And the TSR is part of the Trustee project, which is a major 863 project in China. And TSR is developed by our university, Peking University. And these are the functionalities provided by the software repository. It includes software management, user management, feedback, tag management, trustworthiness evaluation, and some statistics of the resources. And this is the homepage of the system. Actually, you can now access the system via tsr.ow2.org, and it has been installed. And this is the architecture of the TSR system. As you can see, it is a layered architecture, and the below is the storage layer, and the middle is the functional layer, and the up is the interface layer. And TSR system has been widely used in China, and it has been installed in many cities and companies throughout China. And last Thursday, we installed the TSR system for OW2 in Grenoble, and you can visit it. And now, as we are discussing the quality, the software quality, I will introduce some trustworthiness evaluation work in TSR system. And the trustworthiness evaluation is an important part of the TSR system, as you can see in the red rectangle. And actually, there are two kinds of methods to evaluate a resource's trustworthiness. The first is feedback-based trustworthiness evaluation. The second is internet-based trustworthiness evaluation. And first, I will introduce the feedback-based trustworthiness evaluation. The rationale behind this evaluation method is quite straightforward. When I want to reuse a software resource, I will choose the one that has been recommended or identified trustworthy by other users. In other words, users' feedbacks are an important kind of trustworthy evidence. Moreover, if the user is trustworthy, for example, he is an expert in some domain, his feedbacks is more likely to be trustworthy. So we collect users' feedbacks in TSR system and provide feedback-based trustworthiness evaluation to help users to find and reuse software resources. And the feedback-based trustworthiness evaluation is based on the fixed feedback functionalities in TSR system. Actually, there are two kinds of feedbacks supported in TSR system. The first is the simple feedback. You can provide a rating or some comment directly. The second kind is the template-based feedback. You can provide detailed quality details of the software results. For example, you can provide the stabilities, the securities, the portabilities of the software, and you can submit to the TSR system. And the procedure of the FBTE is like this. The TSR administrator assigns some trustworthiness evaluation experts, and then the experts provide their feedbacks based on the quality template, and then the TSR administrator confirms these feedbacks, and the latest overall rating is taken as the software resources trustworthiness level, and it is quite straightforward. But it is widely used in different software repositories and portals, and it is supported in number system as well. And the second kind of evaluation method is internet-based trustworthiness evaluation. And the background is like this. Software resources are changing, and they are changing from closed, static, code-like resources to open, dynamic, service-form resources. And on the other hand, with the development of Web 2.0, there are more and more information on the internet. For example, users would like to provide their feedbacks after using a software resources on different portals. For example, these are the comments collected from the SIGTA, which collect web services, and these are some comments provided by users after reusing the web service. And what we are doing is to try to collect these information scattering on the internet and collect them into the TSR system and use this information to evaluate the software resources trustworthiness. This is the framework. From this, we read the software resource list from the TSR system, and then we collect related information from the internet. And with this information, we extract the trustworthy evidences and then store them into the database. And with these evidences and the trustworthiness evaluation model, we can evaluate the resources trustworthiness. And taking web services, for example, this framework is quite similar to the above one, so I will skip this framework. And actually, we collect diverse kinds of trustworthy evidences for web services. For example, we collect objective trustworthy evidences like the Qth. In fact, we implement a Qth monitor, which invokes every service in the software repository on a regular basis. And with these invocations, we can calculate the quality of the Qth of the web service. For example, its stability, its response time, and its availability. And the second, we collect the subjective evidences, namely the reputation. We calculate a service reputation with users' feedbacks. And as mentioned above, there are two kinds of feedbacks, ratings and comments. Ratings are numbers, so they can be calculated directly. And the comments are written in natural languages, and they can't be calculated directly. So we apply sentiment analysis to the comments. For example, these are the comments collected from the internet, and after sentiment analysis, we can see this is a positive comment. And then we assign the +1 value to the comment. And this is a negative comment, so we assign -1 to the comment. So by applying sentiment analysis, we can calculate service reputation with users' feedbacks. For example, this is a demo. This is a web service named IP2Geo. You supply the IP address, and the service will return you the geolocation information of the IP address. And these are the queued information collected for the service, and these are the feedbacks collected from the internet. And these are converted evidences. With all the information, we can evaluate the service trustworthiness level. And last, I will introduce the Python Lab Data Center. This work is done by Minghui Zhou and Gruen in our lab. What she is doing is try to understand the past and the past of the open source software community, and try to learn some best practices and try to predict the future. And these are some example questions they are researching. The first is how people reuse code over time. The second is which code is reused most often. And the third is what attributes they have. And to study these questions, we have to collect the open source data. So what we are doing is to collect open source data, and we provide an infrastructure for the research. This is the method we are using. We collect the information from the internet, and these are the information collected. It includes the info data and the activity data, and these are the raw data collected from the internet. And by writing some scripts, we can extract more information belong to different levels. And we are keep tracking various commercial and open source projects, which includes the version control systems, the issue tracking system, and the email archives. And these are some statistics of the files we have collected. You can see that we have collected over 26 million files from SourceForge, and this is quite a lot of data. And these are the machines and the storage for the data. Actually, I think there are several terabytes of open source data in the lab, and it is open for and available for researchers. And these are the data levels. And this is the address of the Python lab. And these are some related websites. And actually, all the systems I mentioned about are open source, and you can download it, and you can modify it, and you can use it for free. Thank you.